Europe is moving towards a climate-neutral energy system that's both reliable and affordable. The North Sea plays a key role in this, as it has opportunities for wind energy and hydrogen production. But how can we best make use of this potential while at the same time taking nature and other use into account? This is addressed in the NSE program, a collaboration of more than 30 international parties. In this webinar series, we will dive into the research methodology and the key results from the earlier phases of the NSE program, and we take a look at the next phase. We will talk about energy hubs, ecology, environment, energy markets, and other relevant topics. And, of course, we will talk about the integration of all these subjects and talk about why it's important to look at these topics together. If you have any questions, you can enter them in the chat and our experts will answer them. Today's webinar is on logistics, safety and digitalisation. My name is Hoenderdos. Let me introduce my guests, Poort and Koornneef and Jona Poort. Jona and Joris, nice to have you here.
Yeah.
And let's start with a short introduction. Jona.
Yeah, thanks. My name is Jona Poort. I'm a research scientist at TNO in the Energy and Materials Transition Unit. And within that unit, I apply my background in engineering to many different problems on modeling, optimization and machine learning within the energy transition sector. And that's also where I got involved in the North Sea Energy program.
Okay. How long have you been working for TNO already?
For TNO around 5 years now. And I started, I think, 2-3 years ago with the North Sea Energy 4 program. I was involved when a colleague asked me to join. And since then I've been happily contributing.
Yeah.
Yeah.
Okay. Joris?
Joris Koornneef, work also at TNO. Since 2017 attached to the program as the scientific lead. And that means something like we have a lot of scientific disciplines in the North Sea Energy program. Technology, but also ecology, safety, digitization, also law is being studied and the social aspects. And my job is to combine those different disciplines and make sure that's an integrated program.
Okay, and today we focus on digitalization and safety. And how do these topics relate to the other topics?
Yeah, it's very important. As you may have seen also in other webinars from the North Sea Energy program, it's very busy at the North Sea. There are a lot of different stakeholders there. So it's getting more and more complex, this energy transition. And it's the build out of offshore wind, the phase out of oil and gas. A lot of decisions need to be taken that is really complex. And digitization is typically a trend that can help us as humans with making these different difficult choices and to optimize the energy system further. And safety is, of course, is the centerpiece of what's happening in the offshore. And that is always the most important aspect. So you need to know how safe new technologies are before you implement them, basically.
Mm-hmm. Okay, yeah. And Jona, you're focusing on the logistics of the program.
Yeah.
What for you as a person is interested in that topic?
For me, it's mainly because the logistics, at least in my opinion, is a very important factor in making the energy transition happen. Mm-hmm. So without logistics, you don't have the assets in the first place. Installation doesn't happen. When it's running, of course, logistics make sure that everything goes smoothly and everything is in the right place in the right time. And for me, that's a very fascinating topic to make sure that everything there is optimized and exactly happens when we need it to happen. And also, making sure that this happens in a renewable, in an energy efficient and cost-effective manner is very important.
Yeah, you prepared a presentation as well.
Yes.
So I would like to invite you to give the presentation.
Gladly.
Yeah.
Okay, thanks. Yes, as said, within the North Sea Energy program, me and my team have focused on logistics of the future North Sea Energy area. And specifically, we have looked into the potential benefits of shared offshore logistics in this North Sea Energy area in the future. And we looked into this because, of course, as I already said, I think logistics is a critical enabler service for making the energy transition happen. And as this energy transition occurs and grows, more and more activities will be going on in the North Sea. And as a result, this will also put additional pressure on the logistics system that needs to support it. So we think that sharing logistics between the different sectors active on the North Sea can provide a potential solution to this additional pressure on the system. And why this is important for the energy transition, well, I briefly already touched upon it. It is because logistics is key in all the different life stages of the offshore energy assets. So in order to put them where they need to be, to install them, we need logistics. To maintain them while they are being operated, we need logistics to make sure that everything is in the right place at the right time. And of course, at end of life, when we're decommissioning, logistics again plays a significant role. So as the different sectors start to integrate in this future North Sea energy system, we also see the need for logistics to integrate as well. Because when a wind turbine breaks down in the future, it won't just be the problem of the wind farm operator anymore. It will now also be a problem of the nearby platform on which we are producing hydrogen through electrolysis, which heavily depends on the electricity coming from the wind farm. So we need this integrated and shared logistics system to help us have the system function in a efficient manner such that we can save cost, time, and of course, what is very important, what we're doing all of this for also save emissions. So the way we approach this, evaluating whether the shared logistics could potentially provide benefits, is through quite detailed simulation of offshore maintenance campaigns. So at TNO we have in-house software which can simulate both the planning, the scheduling of offshore activities related to maintenance and operation, as well as calculate the associated costs. And we use this software to simulate various different scenarios that we envisioned might take place in a future North Sea energy system. And then we looked into both a situation in which it was business as usual, so no sharing was happening at all, and a situation in which certain activities could be shared. And then we compared them to see where the benefits may lie. So all of those results are summarized in the figures you see now here on my left. And I'm not going to go into all of them in detail today. I don't have time for that. But if you are interested, all of these results are also in the reports that we have written. So if you go to our North Sea Energy website, they are free to download over there, and you can take your time in digesting them. But some of the key highlights I want to share today is that when we look at these different scenarios and comparing sharing between not sharing, we see that in almost all cases, sharing does give some benefits. However, these are not always as significant, but in many situations, they can also provide very significant savings. For instance, 15% in costs and 50% in emissions under certain scenarios that we evaluated. And this already shows that, at least on paper, sharing logistics can provide very nice benefits in terms of cost and emissions. But of course, putting it into practice will be another major challenge in the future. Of course, we need to get together all different people from different sectors that have different histories and do and operate things differently. So getting those all aligned is, of course, going to be a major challenge. So for me, it is time to start this discussion now, such that in the future, once the system is in place, we have a good foundation for a offshore logistics system that can help support the energy transition.
Okay, Jona, thanks again. Please come back to the table.
Yes.
You were talking about your team. That's the first thing you said.
Yes.
How big is that team?
Well, we were with around 4 people. So, and actually, I think it was mainly two of our colleagues from the wind department that did most of this work. And yeah, they did a very great job, because it's quite a lot of work to evaluate all these different scenarios, dig into the results, and then compare them. So, yeah, my hat goes off to them as well.
Okay, yeah. Joris, that brings me to the larger scale, because how many people in total are involved in the NSE program?
In the past phases and in the new phase, we have up to 40 partners currently working in the program. But if you count them all together, we have, I think, 50, 60 partners. So that is industry, but also science, research institute, NGOs. So a lot of people, a lot of partners. And then within those partners, we sometimes have groups of 5 to 10 people from those partners working in the program. So it's a whole, basically, it's a whole group of experts learning from each other and sharing information on this topic. So that is a hugely interesting part of the program.
Yeah. And Jona, back to you. What for you as a person is the most challenging of the work you do for NSE?
I think for this work that we did, one of the most challenging parts was defining these scenarios. So, of course, a lot is going to happen, but yeah, one of the main things is we don't know yet what is going to happen. That's also why the North Sea Energy Program is here now. So, yeah, we had to think about what could be the scenario in the future, and make sure that, yeah, this is something we could tackle, but also is still relevant for the different stakeholders and for the program in general. So that was quite a big challenge. And then, of course, yeah, doing all the simulations, that's also a very big chunk of time went into that.
And is there within the work you did a so-called eye-opener for you? Did you find something, well, a wow effect or something like that?
Yeah, for me, I think that's a good question. The effect of having an artificial island in place or not is very interesting to me, because yeah, we did these different scenarios. In some cases, we said, okay, what if there's an artificial island from which we could base our operations for the offshore logistics? And when you see that this can have very big effects and it can go both ways. So in some cases, you see that it actually gives more cost, but it's not really beneficial for emissions or other things. But on the other sides, depending on the scenario you look at, for instance, if you're further away in the offshore, then it does contribute significantly in cutting down all the different trips to far away platforms and wind farms. So that just how one it's not simple, but one sort of variable that you change can have such a varying impact that was very interesting to me.
Yeah.
Yeah, I mean, maybe on the relevance of what the Jona's team is doing. If you look at the past years, then you see that the global supply chains are putting on the pressure. So there's a lot of difficulty in maintaining the build-out rate of offshore wind, for instance, to keep on building the new wind, contributing to the targets we have around the North Sea, in the North Sea countries. And this kind of logistics optimization, that part, could be helping us with reducing those pressures on those supply chain, and also in the stress on human capital we have.
Okay, because you are focusing on that as well in your presentation, Joris. It's about safety and digitalisation, and also the artificial part is also part of your presentation. I hope, or maybe not, but we will come and talk about that later. Yeah. But maybe you can do it right away, your presentation. I would like to invite you. Yeah. Please step ahead. And then we go and listen to you.
I'm going to take you to 2 topics today. The first one is safety, and after that I have a short presentation on digitization. 2 important topics in the North Sea Energy Program, as we discussed at the table. I think, as we all know, safety is the most important thing offshore. Offshore companies and people working offshore always have safety as the first point in their operations and into their design of the future energy system. So we also tackled this important topic in the North Sea Energy Program. And we focus today, my presentation, on safety integrity of offshore hydrogen production. As you can see in this picture, we have important elements coming into a platform. This is a platform carrying 500 megawatts of electrolysis capacity, so that's a large amount of hydrogen can be produced on this platform. It needs power, electricity from wind. It also needs fresh water, so that's seawater where we make fresh water from, and we basically bring back the brine, so the more salty water back into the North Sea. And of course we produce hydrogen. This is the system where it operates as we want it to have, and thereby also producing oxygen as a byproduct, and we vent that into the air. So what we did in this study, we did a gas release study, and we basically focused on all of these energy carriers coming in, electricity, water coming in, brine solution being disposed, hydrogen being transported to shore via a pipeline. And we basically analyze the base case operation, so when it runs normally. And in that case, oxygen is being vented from the platform because it has to be disposed of into the air. And we wanted to know basically how that disperses in the air if you operate this platform under normal conditions. And we also analyze situations where the operation does not operate as we want to. So there are accidental releases of for hydrogen. For instance, that could be as a gas being emitted from the inventory. And in certain cases, that could also be ignited. And then there's a heat release that could be harmful for people working on the platform. So we analyzed what could happen in these situations. And what you can see here is an example of a gas release study, in this case for oxygen. And with certain models we have in the North Sea Energy Program, we can then analyze what the concentration is on certain weather events downstream, basically, of the wind direction. And then we can calculate the maximum vertical distance up to a concentration that we consider is harmful, and also the horizontal distance from the platform that we consider as potentially harmful for people or the environment. So if we zoom in here on the analysis, what you can see here on the y-axis is basically the vertical distance up to where the concentration of, in this case, oxygen extends basically in a vertical direction. And on the x-axis you can see the horizontal distance of that oxygen cloud moving downwind. And different colors, they represent different weather classes, where there is a stable atmosphere or a disturbed or a turbulent atmosphere. And the numbers you can see in the picture, they represent the wind speed. So what you can see here is that if the wind speed is higher, basically the oxygen plume moves further, but also the concentration is being extended into that direction. So that means that the weather at a certain moment is important for the dispersion calculations of your oxygen or your hydrogen. If you then take all of these scenarios that we analyzed together, you can see here basically the important distance that you should remember from this consequence analysis. So if you are venting oxygen in a normal operation, you should be taking care of the certain distances from this place where you vent this oxygen, which is about 30 meters. That could be of interest for people working on the platform. If you are venting hydrogen in a situation where the platform does not operate as you want to, the distance is about 38 meters in vertical distance, and the horizontal is 10 meters. And if that plume is also ignited, then the distance is about 50 meters. And in accidental release of hydrogen, and this was the worst case that we assessed, basically these distances of interest to harmful concentrations are up to 93 meters horizontally. And when this is ignited, then it's about 51 meters. So that gives us insight into two important aspects. This kind of effect distances to potentially harmful concentrations, you can incorporate into the design of your offshore hydrogen platform. That's very important to know. And it's also good to know that these distances are within the current 500 meter safety limit that's already in the law for these kinds of facilities. So we could design for it. We also have mitigation measures to control these distances. And it's already fits within the current design limits in the Mining Act. So the next topic is digitalisation. And this topic is best represented by this picture. The future energy system will be complex. You can see electricity coming from wind. Part of this electricity is being converted into hydrogen that's brought to shore. We have blue hydrogen being produced onshore from natural gas. And then that CO2 coming from that blue hydrogen needs to be stored. So we have many different functions in the North Sea that you all have to operate together and design in an efficient way. And therefore we think, as a North Sea Energy Programme, digitization is one of the key trends that can help us basically design but also operate the system effectively and efficiently. We studied quite some aspects that you can do in this domain. So we studied the digital twin aspect, where you have basically a digital copy or representation of your assets so that you can operate it first as a model and then apply this model in real life to operate but also design the energy system better. We have big data analytics. So you can imagine if all these assets at the North Sea are all connected and all have sensors in it, a lot of data is coming in. So we need to have new technologies that analyze this data to make sense of it for us as humans so that we can make decisions based on that. Then we have the group of immersive technologies. I think of that as virtual reality, where you can walk into an offshore platform with your virtual reality glasses on to test the design, but also practice safety measures basically in an operating environment, but being safe. Then we have the Internet of Things with a lot of assets and also sensors being connected to the internet to make to support decisions by it, but also have a lot of data streams coming in on those assets that we have in the North Sea. Then we have a very nice topic of robotics and automation. Think of the talk of Jona, where we have shared logistics. Well, part of this logistics could be done by drones or by vessels that are automatically operated to reduce the human capital needs in the offshore domain. Then we have the topic of sensors. The new offshore energy assets are being more and more equipped with highly advanced sensors to monitor the fatigue, but also the performance of these offshore energy assets. So very important also to develop those further and connect those together so that you have a good picture of what's happening in the North Sea domain. Then the topic of additive manufacturing. That could be a transformative trend in the North Sea, where you have 3D printing of certain elements or components of offshore assets, or that you print in the future whole assets or just part of it as part of operation and maintenance. But of course reducing also the supply chain issues then if this trend goes ahead as we think. Blockchain technology and data sharing, I think that's very important if you think that all of this data is coming from different operators in the North Sea, is that we find a good way of how can you share that without infringing on any competition laws or any privacy issues attached to that. So just as one example, we have explored basically the digital twin aspect, as I explained. What we did there, basically we made a model of wind turbines producing electricity and an offshore hydrogen production platform producing hydrogen from that, so that you can decide to bring electricity or hydrogen to shore, whatever is most economically favorable. And then we make a model, a digital twin of those assets, to find the optimal balance between producing electricity and or hydrogen. And we found if you have such a model, making such decisions for us, we could basically find a more optimal design than we could do by just testing it ourselves. And that brings us at least 4% profit gains if we let it done by the digital twin model. We could also basically let the model decide on how to operate that system. So if it's producing electricity, bringing that to shore, or hydrogen. And if you let that be optimized by the digital twin model, you can increase selling prices by about 19%. So that is a huge economic gain if you look at the whole system. And last but not least, we also tackled the important part, which is about forecasting uncertainties. And that's about understanding the forecast of energy demand onshore, also in relation to the forecast of the weather that is occurring at the North Sea. And with advanced models and AI, we could reduce these forecast errors from 10%, which is pretty high, to about 2%. So that means that you can more accurately decide what you're going to produce to meet the energy demand onshore. Just to give an example of how powerful these kinds of developments could be, we also think that you have to have 3 steps in the next period to take advantage of this trend. First is really develop this digital twin to optimize the energy system integration at the North Sea. And then second, really work on advanced sensors and artificial intelligence, basically, so that you understand what the status quo is of your assets at the North Sea. And then on top of that, if you have that system in place, then you can also think of really autonomous vehicles like drones that do automated inspection, but also repair and maintenance of your offshore assets to basically further reduce cost and reduce the pressure on your supply chain and human capital. Just some examples of what we could do in the North Sea, but even more trends are looming ahead of us.
Yeah, Joris, thanks. I have one question. Your last slide already gave a bit of an answer to my question, but in general, you were talking about safety, you were talking about digitalization, and where and how does those 2 topics meet each other?
Yeah, it's a very good question. I could have also shared that in the presentation, but I think if you have safety, is of course, or human safety is very important. And then one thing in the digitization trends, I explained that you could do more automated operations and inspections and repairs. So you could reduce basically the amount of people that actually work offshore because you do more with robots and drones. But you can also, with the digitization and sensoring, in an earlier phase, sense whether certain materials are, where there's fatigue or what the status is of your equipment. So you can reduce the moment when a certain aspect fails, but you can also reduce the consequences as there are no people working in the offshore anymore.
Okay, thanks. Please have a seat. We continue our conversation, also with Jona, with the 3 of us. Yeah. Joris, let's talk about AI, because that's a really a topic that's everywhere in society at the moment. And if you think of AI and the work you are working on, how do you see AI in 3 or 5 years' time from now for the NSE program?
Yeah. These developments are going very fast. I think one thing is that what we embraced from the former phase in North Sea Energy is this digitalization trend. So we further embrace this as the core in the program, that we do a lot more with data sharing across the different work streams, that we have a central place where we store the data so that we have access to the data and can do more advanced analytics with that data in the North Sea Energy program. That, having said that first, and then AI can help us to basically harness all this data coming in from all those assets in the future energy system. There's a lot of data, terabytes and terabytes pouring in, basically, and you have to make sense of this. So is something wrong? Is it a noise? And AI, so artificial intelligence, can help us, basically being trained by models that we know, can help us make decisions to see, oh, this is an anomaly. There's something happening with this offshore asset. We now have to take an intervention. So AI can do a lot for us in understanding what's happening offshore and help us making decisions as humans.
Yeah, I think that's also going to be very interesting for logistics as well, where now you have sort of a system where you do preventive maintenance. You just go in regular intervals. But with AI and with all this data, you can start thinking about doing predictive maintenance, where using these advanced models, you can make a prediction on when do I expect my asset to need maintenance, such that I don't go there scheduled times, certain weeks apart or whatever, but you go exactly when it's needed, and with that also further optimize and make the system more efficient. So
can you also use a program like ChatGPT in your business?
That's very difficult. For these hard calculations, it's usually quite difficult because it will just make stuff up. It's not very good at calculating, but I think not yet. But it's interesting to see there are ways in linking it to actual models, such that you take advantage of the sort of the language that it knows, because it's very good at at understanding and explaining things in nice language, and then connect that to potential models such that it can sort of, you ask it a question and then it asks the model to do the actual calculations. And I think that could be a very interesting a trend for the future, or helping with the dissemination or that sort of stuff, explaining exactly what we do with a model. So then, well, we don't have to be here anymore.
And which countries do we look at in an AI perspective? Are there any countries that's further ahead than we are?
Well, I think if you look at this digital twin concept, I think we are quite far ahead in the Netherlands. We're also doing a lot, at least in TNO, on this topic. It was a rather small topic a couple of years ago when I just joined TNO, and now it's really big. We use it a lot, and it's only going to be bigger and more important. But of course, there are also challenges attached to it. So, as I explained, the data sharing. That is a hurdle that we need to find a way out, basically, to how can we share all of this data that's coming from the North Sea, and then make it so that we can make use of it in a nice way, but not infringing on any of the safety concerns. Is it still safe to have this platform being connected to the internet for security reasons? No. And that balance between data sharing and privacy and energy security, that is a very fine balance that we need to find answers on.
Okay. Jona, in logistics, it's a difficult word to pronounce for me.
I do it all the time.
What do you hope to achieve from now on in 3 or 5 years' time?
One of the nice things we would like to achieve also within the program is sort of finding a standard workflow that we can set up to apply to a future energy system. So in the coming periods, there will be coming more clarity on what's actually going on the North Sea, what activities are planned and where, and having sort of a pipeline where that information can be taken and put into sort of our systems would be very nice to achieve, and have one streamlined pipeline for that. And then have very tailored, optimized systems to help support the energy transition. Yeah,
and same question for you, Joris. When will you be happy by the end of 2025? What must happen?
I hope that we have, as a program, have set the first steps towards this digital model or digital twin of the North Sea, to also help working together across sectors, but also across borders with the other countries, so that you have a common goal at the end of this decade, maybe, that you will really have a digital twin in place of this North Sea, so that you can run optimization, but also design models and operation and maintenance algorithms, as Jona explained. If we don't do that, I'm sure that we have a less optimized system that is more difficult to manage in terms of logistics, safety, operations, than if we work together on this in the North Sea basin.
Okay. What are you going to do tomorrow, Jona?
Tomorrow?
Or the day after on this topic?
Well, we're going to start up soon our activities in the next phase of the North Sea project, also together with our partners, and hopefully start the ball rolling.
Yeah. Okay. Well, thank you for now.
Thanks.
You as well, Joris, and thank you, viewers, as well, to this webinar. You can follow the NSE program on LinkedIn as well as on the website of NSE. So thank you again and goodbye.